Okay, so just a reminder that the meeting's being recorded. Please keep yourself muted if you're not going to be speaking, and there's going to be an open slot at the end for questions, so you can join then. Okay, I guess we can officially start. Thank you for joining us, Xavier. Do you want to introduce yourself?
Hello, I'm Xavier Moreau. I'm in charge of strategy and business development at Nuvve, and I've been working in the electric industry for the last almost 20 years, and working on V2G and bidirectional charging since almost 7, 8 years. And today I'm glad to be here to share with you some thoughts on the development of V2G in Europe.
Awesome. Okay, well, I'll add the presentation. I'm Jonathan Robles. I'm working for Nuvve. I'm a project engineer, and I'm involved in the V2M as the main contact through Nuvve.
So maybe a quick introduction of Nuvve in a few words. Nuvve's mission is to electrify intelligently the planet, starting with mobility. What we do is a platform that matches the charging needs of fleets with the needs of power systems for flexibility. We aggregate a tiny portion of electric vehicles' battery to provide flexibility to networks and to buildings. We can come back more into the details later. We're a global company with our headquarters in California, but operations in Europe, so mainly in Denmark and also in Asia. We've been around for quite some time. Our technology stems from patents developed from the late 90s and the early 2000s in the US at the University of Delaware. And we're deploying smart and bidirectional charging infrastructure on passenger vehicles, but also on buses, for example.
Great, thank you for that introduction. I just want to start with sharing this QR code. We want to grab as much info as we can from people's perception on EVs. So if you're watching this after the recording, please feel free to join that QR code, just scan it, and it will be a quick survey. And we would be very grateful if you can give us your input. Okay. There's some delay on my computer. Okay, there it is. Oh, so real quickly, the splash screen for the topic of today: what role can V2G play in the European power system in terms of efficiency? So real quick, we'll have, we just did the intro. We'll go over the basics of what is V2G. We'll cover the V2G side in Europe and how is it relevant. And then at the end, I'll go over a few topics on V2M and the EU and how this paved the way for future V2G environments. And at the end, we'll have a Q&A. And yeah, so I guess we'll start. Xavier, let's just remember that this is the main question we'll come back to. What role can V2G play in the efficiency of the EU's power system? And a reminder that this is being recorded, so just please keep yourself muted, and we'll open the floor at the end. So I guess, can you give us a brief on what is V2G, how does it work, and what are the benefits?
Yeah, sure. So V2G means vehicle to grid. The objective of V2G is to integrate electric vehicles with the power system. On this slide, you can see throughout the day how V2G can operate. First, a quick distinction between vehicle to grid and vehicle to building. Vehicle to building is about exchange of energies between vehicles parked in or next to a building and the building, whereas vehicle to grid goes one step further because it's exchanges of energy between the grid, so the networks, the power system, and the vehicles while they are parked. V2G, in this example, if we start in the morning on the left-hand side, is a way to integrate more renewable energy, because when there is a lot of solar, for example, in the beginning of the afternoon, at the top you can charge the batteries while you are at work and your vehicle is parked in the parking lot of your workplace. While the vehicle is parked, it can provide grid services, as you can see on the right-hand side. Grid services are all the flexibility required by power system to absorb the variations of demand and the variations of energy generation. And then energy that has been charged in the afternoon can be sent back to the building and to the grid to shave the peaks in demands from people coming back home in the evening and starting their electrical appliances. During the night, you might have also abundant electricity from baseload nuclear plants or wind. So it's a good time also to charge your vehicles. And again, this energy charged at night can be given back to the buildings and the grid in the morning. So vehicle to grid and vehicle to building is a technology that requires bidirectional charging, so bidirectional flows of electricity between the car, the building, and the grid, but also bidirectional communication for the vehicles to communicate with the building and the grid, and to agree on how to exchange energy. And this is where Nuvve comes in. Thanks to our aggregation platform, we are able to make this link between the vehicles in the parking lot, in the depot, in the garage, and the needs of the building and the grid, and the available capacities and the flexibility needs.
Great. Just a quick question. Do you see my screen only, or? Because I don't know if the recording is also taking in. No.
Now I see your screen in full screen.
Okay, perfect. Just continue. Thanks. Okay, yeah, well, let's move on. What are the challenges of implementation?
The key challenge to implement a vehicle to grid is a coordination challenge, because you need a system approach to perform vehicle to grid. You need the vehicles that can backfeed energy into the grid on one side, and on the other side you need the grid to take into account this possibility of using the vehicles as a flexibility resource. So this needs also communication. So you need vehicles that can backfeed, can communicate in two ways. You need the charger to be able to communicate on one side with the vehicle, on the other side with the building or the aggregator platform, and to be bidirectional also to allow bidirectional flows of energy. So typically, a charger will have to prevent that energy is fed back into the grid if the grid is down, to avoid any electrical shock to a worker that would be repairing a line that is down. So you need some protection system, additional protection systems, which do not exist in a regular charger, because with a regular charger, there's no risk of energy going back into the grid when it's down. Regarding the communication, you need to speak the same language, because the vehicles are mobile, they can move around, so every charging point should be able to understand what the vehicles tell them. And so some standards and protocols are being agreed on to enable this communication.
Okay. You covered this one. How does V2G differ from vehicle to home and vehicle to building?
Well,
you
yeah,
covered it a bit.
vehicle to home is a subset of vehicle to building. The vehicle to home usually is about maximizing any locally produced energy. When you have rooftop PV, for example, if you want to store the excess rooftop PV, you can use your vehicle in a vehicle to home setting. In some countries where the grid is weak, vehicle to home is also used as a backup system should the grid drop, then you can supply your home from your vehicle.
This is just a reminder for the QR code survey.
Yeah, this survey is important. It's part of our V2 market project, and it's to gather information to feed our research as part of that project.
Okay, so I guess we're now getting into the second part. Why is V2G especially relevant in Europe?
Well, that's yeah, that's a key aspect. What you should know is that the European Union is not autonomous for its energy. It depends for, I think it's 63% of its energy on the rest of the world, so on imported energy. So 2/3 of its energy is being imported mainly as fossil fuels. So this creates a high dependency on not so reliable nations. When you get your gas from Russia or your oil from nice governments such as Saudi Arabia, of course, this creates, this weakens your capacity to assert your power in the world. Energy independence is a key topic for Europeans. Today, 30% of energy is produced in Europe, of which 2/3 is CO2 free. So basically, you have 43% of energy produced in Europe, which comes from renewables, hydro, wind, solar, and 28% comes from nuclear. Having said that, there is a huge challenge for Europe to develop its local resources, which are mainly renewables and somewhat nuclear. This means if you develop renewables, much more variability in your power supply. And to address this variability, V2G is a key solution because it offers a buffer to absorb the variability of the production of renewable energy. The objective for Europe is really to create a symbiosis between variable renewables such as wind and solar on one side, and its fleet of electric vehicles that can act as a buffer to dampen these variations from renewables. What you should know is that it's estimated that electric vehicles will represent 5% of electricity consumption in Europe in 2030. So in terms of consumption, it's not really significant. I mean, 5% additional of the consumption, the system can cope with it. But what's more interesting is that some sources like DNV or the IEA expect between 48 and 56 million electric vehicles to be on European roads in 2030. If we take the assumption that each has a battery of 50 kilowatt hours, it would mean that in 2030 we can have around 2.5 terawatt hours of storage in European parking lots, in European garage, in European depots. So this is huge, 2.5 terawatt hours. That's more or less, a bit more than 10 times what can be stored in pumped hydro storage. So the dams where we, for example, in the Alps, where we store water in the winter and we use it to produce electricity. This huge virtual battery is a key asset for Europe in its path to decarbonization and energy independence.
Great. So now we'll move on to the market side and how that would play out. So we have the wholesale markets and the local flexibility markets. And can you explain the exploitation pathways for these markets?
Yes, so once you've defined the strategy that you want to leverage the flexibility capabilities of electric vehicles to enable a higher penetration of renewables, you have to put in place the ways to make it happen. And the approach is to use the power of markets to optimize the resource allocations. And for V2G, there are and for electricity in general, there are two main approaches. First, we can go through wholesale markets where energy is traded, electricity is traded, so on several time scales. When you store electricity in a vehicle, you can store it for a few days up to a week. Usually, if you drive, let's say, 30 kilometers per day, you will recharge once every 2 weeks at least. So it means the time scale we're talking about is in days. It's not in months like pumped hydro storage, but and on this time scale, you have 3 markets where electric vehicles can play to be incentivized to absorb the variability of renewables. So the day-ahead market, where 1 day before you can commit to purchasing electricity or selling electricity on the market, and then intraday auctions or intraday continuous markets are 2 markets within the day where you can adjust depending on the prices and your capabilities to absorb electricity or to backfeed electricity into the system. One example, I come back home in the evening. I know that tomorrow I won't use much my car, or that I will be in the office for 8 hours. I can bid the capacity of my battery for those 8 hours where my car will be parked to purchase electricity after the morning peak when consumption goes down. For example, because the prices are low, so I purchase electricity at a low price, and then I sell back my electricity later when prices go up. For example, if the weather forecast makes it likely that there will be less sun power than expected in the afternoon, and so prices go a bit higher. Of course, this cannot be a manual process, and that's where you need automation, and you need platforms like the Nuvve platform to perform that on your behalf, to optimize the use of your battery on your behalf.
Right. That's one question I think that came up often during the meetings with the consortium for the V2M project, where people had this concept of performing V2G, V2X, V2H, V2V with the user being in control. That's what they had in mind. And although that's certainly a possibility in the future, it does add way more complexity than to have an organization like
Indeed,
Nuvve controlling
indeed.
the aggregation process.
So
It
it's
makes it
key.
trickier.
Yeah, this is a key point. The first use of a vehicle is to move people or goods around. So
Right.
V2G comes on top. It's an afterthought almost. So the priority should always be to ensure that the driver will have enough energy for its daily duties. So that's the first priority. It's the main constraint of all our optimization algorithms because V2G is a marginal use of the vehicle, but it's also a fantastic benefit because it means an asset, a vehicle that is used only 5% of the time and is spending 95% of the time parked in a garage or at the depot. Can see its utilization greatly increased if you maintain the trust of drivers that they can rely on their vehicle. It will be available when they need it. So that's what Nuvve does. We take into account these constraints. With these constraints, the external data such as prices, weather forecast, and technical parameters, we run optimization algorithms and we aggregate a tiny portion of the battery of a huge number of vehicles to create a virtual power plants that bids on those day-ahead markets or intraday markets.
Perfect. And I guess we can continue with the local flexibility markets, explaining the short-term and long-term side. It's just another part of what V2G can tackle, right? In terms of the energy trade, current energy trade system. And
yes.
Yeah.
So wholesale markets are at the scale of a country or even Europe because we have interconnection between the various countries in Europe. Whereas local flexibility markets is an emerging concept where to address the need for flexibility at a local level. You need flexibility at a local level because the variations of renewable can have a huge impact on the grids, on the local grids, typically on the local transformer, which is down the street, and on the feeder, which is below the street in the city. For example, in the beginning of the afternoon, when all rooftop PV in a city is generating at its peak power, you can have an overflow of energy into this very local part of the grid. And because it's very local to where you have a weak grid, because the substation was sized 20 years ago before when energy was flowing only from the grid to the consumers, and not designed to accept energy flowing back from what are now prosumers back into the grid. So you end up with transformers overheating, feeders which diameter is too small to cope with this excess of energy, and you need some local flexibility. So typically, this local flexibility is the capability for some resources at a local level to absorb excess solar in the early afternoon. It can be the opposite. It can be a feeder of a grid which is undersized to serve some peak loads from at very specific times of the year. To address these needs, you can either reinforce the grid by adding more transformers or replacing the substation with a bigger transformer, replacing the cables with a higher section of cables. But this requires civil works. It's very lengthy. You have all the permitting issue. So an alternative that's emerging is to create a local market where the grid operator, the local network operator, will ask stakeholders to offer their flexibility to cope with this local congestion in the grid. So this can be done on two time horizons, either short term, so the network operator foresees that in the coming season, in the coming week, in the coming days, he will face an issue on his grid, or it can be long term because they know that structurally their grid in this area, in this specific part, is weak. So this is something, for example, you see in the Nordics where heating is electric, mainly with whether heat pumps or radiative heating. So you have peaks in winter, which are very short and only during the winter. So it would be an overkill to upgrade the network just for this. But by creating a local flexibility market, they are able to harness the flexibility of various distributed energy resources to cope with those peaks. And electric vehicles are very well suited for this. Short-term, individual users know their driving patterns. And long term, it's maybe more suited for fleets which have regular patterns which can be predicted. So we see this as a huge opportunity. Because it's quite local, maybe the competition is a bit less stronger than on wholesale market because less liquidity with only local players can bid in those local markets. But it's still a very interesting alternative for network operators to use to address these constraints.
Right. Thank you, Xavier. Another reminder to get your input, please scan that QR code and fill in the survey. All right, we'll move on to the last part for the second half. Regulations, EPBD and AFIR. What are they and how can they impact the implementation of this technology?
Yeah, so technically, V2G works. At Nuvve, we've been operating V2G fleets for close to 8 years in commercial settings, where for fleets of various fleets who have significant operations, for example, in Denmark, where we have fleets of vehicles that provide ancillary services to the grid, such as frequency regulation. But for this technology to be widespread, we need the right regulatory frameworks to foster it and enable it. V2G is about scale. It's by aggregating hundreds of thousands, if not millions of vehicles that it can have a very significant impact and address the challenges on the grid. And the European Union is well aware of this and worked on several regulations and directives to enable V2G. Just taking a step back, I mentioned the challenges of Europe to become more or less dependent, if not energy independent, and to decarbonize its electricity mix. For that, a huge, an initiative called the Green Deal, the European Green Deal, led to a package of regulation called the Fit for 55, which intends to ensure the European Union is ready to or can reduce its emissions by 55% by 2030 and be carbon neutral by 2050. So it's a very comprehensive set of laws, the climate laws that was adopted in the last years, among which are several. So you mentioned the AFIR, so it's the Alternative Fuel Infrastructure Regulation. So it's a law about mainly electric vehicle charging. And in this law is mandated that European member states assess the potential of V2G to contribute to the power system. So member states are doing what is called a resource adequacy assessment. So looking at all energy resources in the country and see how they can match the demand. And what is required by this AFIR is that member states, when they do this resource adequacy, they take into account the capabilities of V2G because it's a flexibility resource that's available at a marginal cost for the European power system. Most of the cost of V2G having been paid by the need for mobility. When you purchase a car, it's first and foremost to drive around. V2G comes on top at a marginal cost. So that's the AFIR. Another part of this Fit for 55 package is the Renewable Energy Directive, which aims to foster the penetration of renewables. And these renewable energy directives mandates that new recharging points can be bidirectional so that they are future-proof because they see bidirectional charging as a way to, as I explained, to allow for more penetration of renewables. Another piece of legislation is the EPBD, Energy Performance of Buildings Directive, which mandates that member states ensure recharging points are capable, where appropriate, of bidirectional charging. So why is this in a directive targeting buildings? Well, it's because vehicles are parked most of the time, 95% of their time, they are parked in buildings or next to buildings. Whether it's workplaces, industrial buildings, commercial buildings, shops, stores, or habitation buildings, or next to the building. So there is a clear possibility of synergies between the batteries sitting in the parking lot and the building. Especially with solar, when people are parked at work, it's exactly at the time when solar on the office is producing the most. So there's a huge benefit to combine the synergies. So that's why this piece of legislation, the EPBD, is really mandating member states to consider and bidirectional charging for recharging points. So hopefully this will trigger the deployment of bidirectional capable recharging infrastructure throughout Europe in the coming years. And with this infrastructure capable of V2G, this is a huge incentive for automakers to propose vehicles that are V2G capable.
Okay, for this next one, I know it's a bit tricky, but I wanted to bring it up just to start the conversation. Like I said earlier during the meetings with the V2M consortium, we were discussing how V2G would be applicable in the future. And, as of now, we're doing V2G, but with fleets. So we're talking municipalities or private companies who have electrified their vehicles for whatever operations they need, and we are managing them, right? So that makes sense to me. We're doing it already in multiple countries, and it works pretty well for the most part. It's flawless. But when it comes to a customer who's like, looking into the early adopters that they're already transitioning into EV for the home, and hopefully soon more EVs will be bidirectionally capable. what can they do now to begin this, like, next step forward, to implement V2G, or I mean, in this case, it would start with V1G, obviously.
Well, now that this European legislative framework has been adopted and the AFIR came into force last April, the EPBD and the Renewable Energy Directive also have been adopted, there is a clear direction of travel, and all stakeholders in the market, so the grid operators, the automakers, the political stakeholders, everyone knows in which direction we are going. We are going in the direction of vehicles that are capable to support the grid, to absorb the variability of renewables, and to provide services to the power system. With this visibility, it's now possible for industrial players to develop products to reap the benefits of vehicle-to-grid. And now that consumers know that, they should future-proof their infrastructure, because since the direction of travel is known, it would be crazy, for example, to install today in 2024 a charger that is not future-proof, because otherwise, if your infrastructure, which will be installed now, which will last 10 years, locks you into a system that's not future-proof, you will end up in a few years down the line with a stranded asset, with a vehicle that is useless 95% of the time, because you cannot do bidirectional charging with it. So right now, when deploying charging infrastructure, for example, you can already start thinking of how this infrastructure will be able to evolve in the future to accommodate bidirectional charging. So it's about having in mind that in a few years' time, you can charge your car with solar from the roof or from solar canopies on the parking. It's really ensuring that the cabling will be able to cope with the additional devices to ensure protection when you implement bidirectional charging. And as of today, like you said, you can start with what is called V1G. V1G is also called smart charging, which is about postponing the charge to the best possible time. And for example, at Nuvve, we are developing some AI algorithms, artificial intelligence that will analyze your charging patterns. And with that and weather forecast, predict when is the best time to charge your vehicle. So when the vehicle comes back in the evening, the driver just plugs it in, but instead of starting to charge immediately, the algorithm will schedule the charge at the best time. The best time can be when the electricity will be the cheapest, or when the electricity will be the greenest, because a lot of renewable energy will be available. This schedule is forecasted and planned in a way that the driver can be fully confident that when he will need his vehicle, he will have enough energy for his expected driving.
Okay, which this next one ties into that same scenario. If we can tie it, that would be nice. So now we're a couple of years in. There's more V2G capable EVs. So your impression on local flexibility markets is having an individual participating in this market a feasible option? Yes, without the, say, Nuvve in place, like the aggregator, right?
You have several countries in Europe which are already experiencing some congestion on their grids. For example, in the Netherlands, there's so much solar in some places and at some time that the grids cannot cope with additional connection of electric vehicles or PV generation. One way to work around this is to agree to provide some local flexibility, which can be sourced by the local operator through a local flexibility market. And without upgrading the grid, thanks to this flexibility the operator can source on a local flexibility market, it can accommodate more electric vehicle charging or more solar generation without delays, without letting new PV farms waiting for years or new electric charging station waiting for months for a new interconnection. However, to do this, it's a numbers game. So you need some aggregation, and the grid operator cannot cope with every individual user to participate. It would add a huge number of data points, and their IT system are not fit for it. And there are specialized players like Nuvve who have the skills to do this aggregation. Because when you aggregate vehicles, you have to take into account for the uncertainty linked with electric vehicles. A driver might decide whenever they need to take his vehicle and drive away. It might come back with a level of energy remaining in its battery that is lower than what would have been expected. So this is the core skill of aggregators. To match this uncertainty with volumes of assets. And Nuvve is extremely good at addressing the uncertainty specific to electric mobility, to aggregate all those vehicles in a virtual power plant, a pool of vehicles that provides enough confidence to the power system operator. This is a block of flexibility it can rely on, and therefore it can put a price on it to purchase this flexibility. Also, the aggregators or operators such as Nuvve remove all the complexity for individual users by automating all of these tasks.
I'm glad you mentioned the threshold to participate. You know, you need an aggregated pool big enough to actually market the energy, to bring that energy back into market. And that's something we run into our, I say, obstacles within the Spanish project that we developed with the V2M.
Yeah, so maybe you can tell us a bit more about V2 market, which was studying what was how market could be adapted to leverage the capabilities of V2G, and the V2 market took Spain as a playground. Could you tell us more about how it paved the way for future V2G environments?
Yeah, so for the V2M, we focused on 2 pilots. We participated with, well, the consortium was made up of different areas of the industry, of actors throughout the industry. And what we did is we ran some simulated pilots in which we aggregated a pool of vehicles, and we had the OMIE, the nominated electricity market operator for the Iberian Peninsula, kind of opened their back door to allow us to participate in this simulated scenario. Here we have OMIE at the right. I don't know if you see my mouse.
Yep.
They provided the platform for us to create some bids in the project. So the goal of the V2M was to boost the pace of V2G and V2X and V2H in Spain, but not only for Spain. It was just that was the playground we had, but it really is for the whole of Europe. You know, for other countries to follow. And as you know, the Nordics are more. Sorry, this is an automated energy saving light. The Nordics are way more advanced right now, the energy markets, and we have the southern parts of Europe that need to kind of catch up a bit in that sense. And this project was aimed at doing some, you know, some R&D, I would say, and getting our feet wet in this V2G scenario. And you know, since the technology is quite new and the decentralized energy market participation is not considered yet, or was not considered at the time of the project, this allowed us to kind of circumvent any roadblocks by getting a mandate to participate in this pilot without, you know, being too blocked by the lack of regulation that doesn't exist right now. So what was your other question? Sorry,
Yeah,
kind of.
well, what do you see as solutions for the lag in the implementation of V2G technology in Spain?
So for the V2M, we can see that the best way to go forward is to apply a battery as a service function, which would it would involve using the market to boost this technology through for residential and also fleets, and having that transition into the an electrification transition
Okay,
happen
so it's
sooner.
to remove the burden of the initial investment from the end users. You take the savings from the participation in the market by charging when electricity is cheap and discharging when it's higher price. And with those
Right,
savings and revenues, you are able to pay for the infrastructure. So instead of purchasing the equipment, the end user just purchases a charging service,
exactly.
smart
So
or
it's kind
V2G smart charging service.
of like leasing a car, like a normal internal combustion engine car, but now you're kind of leasing the battery in a way. And then I mean, it's still up in the air, you know. We're trying to. We came up with some partners came up with some sample contracts that others can use to explore this idea. And
So one of the outcome of this V2 Market project was templates for energy services contract for V2G.
yes, that's one of them. And for the pilots, we had two different pilots. One focusing on residential, which was really V1G, because the chargers that were set up for it was through Hola Luz. They were just AC one direction charger. So we weren't able to actually do a full V2G site in the residential
But
part.
with V1G and the prices from OMIE, we are able to schedule the charge at the cheapest time, right?
Right. That's what that was pilot two. So we had two pilots. Pilot one was with IMB, and then the second one was Hola Luz, and we were trying to nudge the users to shift their charging schedules based on a price analysis that we would perform. That we would then communicate to Hola Luz these windows of time to shift their charging sessions, and they would communicate with the customers. So it was kind of a fun experiment there of a simple V1G, I guess like old school V1G, if you could say that. And then for the first pilot with AMB, we actually had three V2G chargers installed, and then they already had their some EVSE, so electric vehicle supply equipment, installed. So they added that pool. That's why it says 17 business fleet cars. We only participated with 3 of those.
But
and then
so
we
I understand in Spain there's today a threshold for market
yeah,
participation, which I
that's what
believe.
I wanted to get to. The threshold we had to simulate. We had to simulate a threshold of 0.1 megawatt. So 0.1 megawatt
So that would be 10 cars?
Yeah, about.
Okay.
I would say more, because you do have that depleted status sometimes, as we've seen. So
So
you need
a safety margin to cope with the
yeah,
uncertainty
because
of
you're
the
not gonna
driving
have all 10.
patterns.
You're not gonna have all 10 at the same time aggregated. So you need the margin of error there to take into account. So we did that, and we
So
ran into
could
some roadblocks to participate. As you know, at the beginning last year, we were having a lot of pushback due to the grid codes, and that's something that needs to be resolved. And yeah, it was a good learning opportunity for all the partners, and it's definitely a step forward in the right direction.
And so in Spain, the next step in the short term, until all the European regulation is implemented in Spain, uh, could we work with dynamic tariff to reap the benefits of V2G? Because I believe they already exist in Spain, right?
Yeah, that's something that can be worked on. As you know, for the European Commission, they said to not wait for them. We were in Brussels a couple of weeks ago, and we had them say verbatim to not wait for Brussels, to start implementing these technology, and do not wait for the regulation to be in place, because we don't know how long it's going to take. So definitely the use of the dynamic tariffs is something that we could start with, and just simply with V1G, which is something we know really well, and we know others are doing as well. So yeah, I would say that's the path, the next step, to start developing this in Spain and other countries as well that are not there yet in terms of the energy market
Can we talk
opening.
about the users, the drivers, before we move to the Q&A?
Yeah, you mean
So,
for
Jonathan, you're operating the fleets of vehicles managed by Nuvve in Denmark. Can you tell
right?
us what's the feedback from users in Denmark? Do they see any impact, or
Well,
can you tell us more
for the
about your
most part,
operations?
it's quite positive. I, as you know, I've been here for almost a year dealing with the Nuvve operations in Denmark, and for the most part, it's positive. I would say they don't notice that we're here, managing their energy, which is what we want. Yeah, I think we're tackling this in a very, very good way. We have our here. Let me actually, I added the fleet box. So this is a view of Frederiksberg, which is our oldest, which is the oldest commercial run V2G environment in the world. And this is a
Yeah,
screenshot from yesterday, actually.
almost 8 years of operations.
And we actually we had a marketing kind of exercise where we interviewed one of the persons. It should be coming up soon publicly, but yeah, they were saying that they don't notice they don't notice us, and that's great. So we just make sure their vehicles are charged at the right time for their trips, and
So I can see on that screen that each vehicle has a target state of charge, right? And some are doing V2G until
yeah. For example, here we have a Frederiksberg Forsuning 515. This unit at this particular time of the screenshot would be able to participate in the market, and the aggregator was taking control of the battery and possibly, very likely, feeding back. You can't tell by the picture, and we only can see post the activity, right? What it's doing. So maybe
in that example,
couple minutes for.
I can see that it's at 59% state of charge and currently doing V2G, whereas the target is 80%. So it means the aggregation platform has estimated there is still enough time before departure to charge to 80% so that it will be ready at the time of departure, and in the meanwhile perform V2G services, right?
That's exactly right. So in that margin that we have to reach the target, we would participate in the market. Excuse me. And yeah, so we would calculate, well, we don't, the algorithms do it, but they calculate the time to charge and the time for the vehicle to, the window of the time for the vehicle to leave for the whatever operations this municipality has. Well, actually, yeah, for Suning. And then we have this one is Bornholm. Same situation as before. We have a unit charging, one that's just plugged, so it's kind of in standby, ready to perform whether a charge or a discharge. This one's doing a V2G over here. This one's offline, so I would need to go figure out what's going on there and contact the client. But very likely the unit's also charging the vehicle. So
this means that a benefit for the customer is because Nuvve is using their charging infrastructure to do services. There's a aligned incentive to have the best uptime possible and to maintain the infrastructure all the time.
So the fleet operators don't only have to just do their job and not worry about the charging infrastructure. We take care of that part. And sure, there's a close connection with them, and we communicate whatever we find. And the goal obviously is to keep the cars running and ready to go. And with that comes the charger. So yeah, it's for the most part has been a seamless operation.
So we have just a few minutes left.
I go real quick. This is just the A and B site. We have one of the cars plugged in. That was from yesterday, and just a sample of the fleet schedule. So I wanted to get to this real quick. So the fleet operator would set up their time window from our they would set up the time window for the trips of each of their vehicles. They could be aggregated into one trip or individual, and it could be a recurring schedule or a one-time schedule. And that's what we know. That's what we grab from them, the information we need and their desired range, and then we operate around those targets. And the last thing, the servitization part, that's one of the outputs of the V2M. Basically, the user would own the car and the fleets be used to, participate in the market. Yeah, I guess we can move on to the Q&A.
Yes.
If there's any questions, let me
move to the next slide with the QR code. Should anyone want to have the link again?
Yeah, we have 4 online use attendance, but there might be some. Thank you, interesting webinar. Sorry, I had to jump. That's not a question. I'll leave this. I don't know if we'll have any questions this time around, but I'm sure they'll write in later. Do you have any closing remarks, Xavier?
So just as closing remarks, my main message is that the European legislative framework is now in place. So the direction of travel is clear. V2G is coming. With projects such as V2 Market, we studies how V2G could be part of the energy stakeholders in the power system and the market. So now let's do it.
Yeah, I guess one thing that we can point on is that we need everyone on board. We need the different players, the regulators, the operators, the grid operators to jump along this shift in technology, which is something that the technology is ahead of the regulation, and it's normal to have these hurdles where thresholds to operate, what is the correct process and procedure for bringing up a site online that's V2G capable. That's something that we still have to see in Spain, and I guess those are the challenges ahead for us and everyone in the energy sector that wants to participate.
A few words about the other webinars of V2 Market.
Well, just there's a link on the chat, and you can go to v2marketproject.eu, and yeah, there's way more content there to learn about the project and yeah, what's coming. And yeah, there's many ways to get involved, and mainly the QR code. If you scan that, that's our one of our KPIs. We need to get more info from users. I guess that's all from my
Thank
side.
you. Thank
All
you
right,
very
thank you,
much.
Xavier.
Bye-bye.
Take care. Bye. I'll stop recording now. Hey, Sebastian Quantan, thank you for joining us. I was hoping
was
you
very
guys
good.
had some. Oh,
Yes.
I see your question now.
Yeah, but it was already after a while, so I mean it's good to keep on 1 hour slot.
Sorry about that.
I need also to jump after to something else. So
Well, I'll send you the recording, man. Thank you for.
yeah, sure. Thank you.
We finally got it done. Sorry about all the rescheduling.
Yeah, no problem. Thank you for organizing everything
Of course.
yeah, I will come back to you I think soon for the ownership agreement because they were well. I will send you a mail soon.
Sounds good. All right. Thanks.
See you.
See ya.
Bye.
Bye.